This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome everyone to Software Engineering Radio today. I'll be your host. My name's Kim Carter, and today we have Zane Lakey as guest on the show. Zane Lakey is the founder and Chief Security Officer at Signal Sciences. He serves on the advisory boards of the Internet Bug Bounty Program and the US State Department-backed Open Technology Fund. Zane was previously Director of Security Engineering at Etsy and a Senior Security Consultant at ISEC Partners. Zane has been featured in many notable media outlets, is a frequent speaker at top industry conferences, and is a contributing author for Mobile Application Security, Hacking Exposed, Web 2.0, and Hacking Voice over IP. Welcome to today's show, Zane.
Hey, Kim, thanks for having me on. I really appreciate it. Looking forward to the conversation.
Today we're going to be discussing application security and how it applies to software engineers. What are the assets an attacker may target? What are the risks to those assets? And the types of countermeasures we need to be thinking about in order to mitigate the risks. There's some relevant articles from the IEEE Computer Society on today's topic. We've got Web Application Security, Threats, Countermeasures and Pitfalls. And that can be found at computer.org/CSDL. We had a show on Docker security with Diego Monica. That was show number 290. And we've also looked at bringing the security focus up front with a show on DevSecOps with Francis Reynard. That was show number 288. In the discussions Zane and myself had leading up to today's show, we discussed how many types of security are being pushed toward the application layer. With that, Software Engineering Radio had a show called Web App Security in 2009 with Bruce Sams. That was show number 128. And I had Haroon Meer recently on the show discussing network security, and that's show number 302. And leading up to today's show, Zane and myself discussed where we think the lowest hanging fruit is in terms of exploiting organisations via information security defects. Today's show really leads on from the last show I recorded with Haroon Meer around network security. We're just going to start with some basic questions to start with. What are the most effective attack techniques for the most common vulnerabilities today?
Yeah, so I think the way in which you've kind of attacked organizations has really changed over time here, and that's why I think it's kind of exciting to both talk about the web application side of things as we are going to today, as well as the conversation you got to have with Haroon of kind of the changing nature of attacking endpoints and things on that side of things. So, I mean, if you look at how attackers have really targeted organizations historically, I mean, we're talking, 10, 15, 20 years ago, you really attacked the infrastructure. Right, you'd go Nmap a given organization's IP range, you'd find something there, and you'd go really attack that at the infrastructure layer. And if you look at how, because of the kind of changing infrastructure topologies and everything like that, you look at how most attackers target organizations today, and it's really shifted either up to the application layer or it's shifted out to the endpoint side of things. And so I think the balance of those two, and really the conversation you got to have with Haroon and the focus today on the web application side of things, I think from a defensive perspective, that's really where so many of us are thinking about how do we adapt our security programs to really cover where the attackers have gone to. So I think, for the application layer in particular, it didn't shift there because attackers woke up one day and suddenly wanted to start attacking applications or anything like that. You look at, how do organizations actually store data and interact with that data, and that's really the data that the attackers are after in the first place. And you look at how it used to be a variety of kind of custom ways in which organizations would interact with the data that they have, and now you flash forward to today, and it's done via web applications, right? It might be done via a standard kind of browser web application, or done via a mobile application that's backed by some sort of web service or something like that, and an API there. But so much of how we create and store and access data as organizations today is really done via the web layer.
In terms of application security, as software engineers, what are our biggest concerns and how do we fix these?
Yeah, so our concerns are many, and how we fix them is can be complicated. I think the big thing that shifted on the concern side of things is really that in the past, when people have talked about web application security issues, they've really meant kind of OWASP injection sort of issues, right? SQL injection and XSS and things like that. And don't get me wrong, those are absolutely important. But what's so funny is when you talk with development teams or DevOps teams or security folks dealing with web applications or APIs, so much of what actually keeps them up at night is attacks on the business logic. It's application misuse, it's account takeovers against your customers, it's application level DDoSes and things like that. And so I think from the, what's kind of changed from the threat side of things, it's that there's just kind of a broader attack surface there, and it's no longer just the classic input validation injection issues that we've known over the past. And then how do we start to address those? I think the biggest thing, and we can really, jump down a few levels here over the course of the show, but I'd say from, a starting top viewpoint, it's really that security tools and techniques can't only be consumed by security people anymore. That this shift to DevOps, this shift to cloud, the fact that applications are being created and delivered so much faster and so much faster now, it really means that for security tooling, the development teams and the DevOps teams need to be able to be kind of self-sufficient with security. And whether that's getting visibility into where and how they're being attacked, or having, different static analysis tools or different security tools that they can consume themselves. But I think the big shift for us as security professionals is we used to really have security tools that were only directly consumable by the security team. And I think that's really shifted to how do we empower the development teams and DevOps teams with security tools that they can consume directly.
It's a familiar topic, shifting security left or shifting it into the development teams, something that engineers have really got to come to grips with.
I think that from that perspective, I think there's a lot of reasons pushing on that, right? I think that the shift to DevOps and cloud and moving things faster is one pressure. The other pressure that we're all feeling from the security side is that nobody can hire, right? There's 1 million open headcount compared to how many people there actually are to fill those roles. And so the only way security keeps up is exactly as you just said. It's really that kind of shift left, get security into the hands of the developers and the DevOps teams.
How are our attackers gaining access to our organisation's assets, and what do we need to do as software engineers in order to mitigate this?
Yeah, I think a lot of this from my kind of experiences going through this shift to DevOps and cloud and everything there was really about how can we give our development teams and our DevOps teams visibility into how their applications are actually being used and attacked. And as those teams, as you're saying, as they're kind of getting more assets and everything like that, more of that data is shifting up to the application level. From a security perspective, what I've really seen be successful both in my own past and with the organizations I talk to today is really about giving them that visibility so they can say, oh, this API that we put out there that we thought nobody was using, actually there's a partner that's completely abusing it. Or these microservices that we were planning to be launching, how do we actually know when someone is attacking them or anything like that? And so getting them that level of visibility, so at the same time that they're creating new assets and having new data and everything that they're collecting from users or providing to your customers or anything there, that they have the visibility from the security side that goes along with that, so that they can really own the self-sufficiency of defending those services that they're providing.
I think one really important thing that I try and do is to get a security champion into the development team to help all the other engineers basically catch on to what they need to do in order to move forward in terms of security and infect the rest of the team.
Yeah, exactly. In the good usage of that term, yeah. I think that's very much what you see many organizations doing, which is embedding security into those teams. Sometimes that's by taking a developer that's already on the team and training them in security. Sometimes it's bringing a security person from the security team to just kind of go be dedicated to that particular development team and work with them. I've seen both ways be successful, but I think the overall theme that we're all really going through is that, you know, there's more assets at the web layer now than there ever used to be. Those applications are being written and changed even, you know, orders of magnitude faster than they used to be. And security isn't able to hire nearly as fast as we need to be. And so the only way in which we actually scale as defenders is by working with the development groups and DevOps teams. And that's really why I say why I say defenders, is that's not just security people anymore. It could just be that engineer on the development team who's been trained a little bit in security and really helps that development group think about it from the beginning.
Yeah, what I hear quite frequently is, as a development team, why do we even care about security? And are we now responsible for the security of the organizations we work for?
Yeah, you know, it's one of those where I certainly heard a bit of those, I would say, in the past, you know, a fairly long time ago, of the should we care about security, or, you know, we don't care about security, or something like that. I really have not found that to be true over the last several years. That I think that really folks are recognizing that security is a subset of good software engineering. Just like performance, just like reliability, just like operability. And so security being a piece of that, it means it's not some isolated, specialized sort of thing. It's part of good engineering. And I think the engineering side has really started to figure that out. I think security is just starting to see that shift is starting to take place. And I think the challenge for many organizations is that they have software engineers or DevOps teams that want to do things well from the security side, but the security tools have not really been written to keep up, right? They've only been usable by security folks, or you turn on kind of a legacy approach to static analysis or something, it spits out 10,000 false positives. And if you're committing, you know, if you're shipping to production once a week now or once a day, you can't possibly run that as your security control there. So really adapting the technologies and the techniques to the fact that folks are recognizing security as a piece of quality engineering.
Yeah, it could be a New Zealand specific thing that I seem to come across quite a bit.
Totally. No, I think it's one of those that changes over time, right? I think that that as we're embracing DevOps and cloud, it kind of shifts the way we do software development. So
yeah, so I'm just going to move into a section now around our top threats, what we see as being our top threats in the industry at the moment. Mm-hmm. If you look at the likes of the OWASP top 10 over the past 14 years, the defects we continue to add to our applications haven't changed that much, it seems. As an industry, what is your take on whether we're actually improving? If not, why not? And the age-old question, how do we fix this?
Sure. So I think there's kind of the are we improving? I'd say the other side of the question is really, are we changing? And I would say I'd say you'd be hard-pressed to find an organization that doesn't feel like they're going through some pretty radical changes in the way that they create and deliver software. I mean, it was super jarring for me in my career because I went from consulting with ISEC partners, where my last project was with a U.S. healthcare company that deployed once every 18 months. And I went in and started as the head of security at Etsy, and they sat me down and said, we deploy to production 20 times a day, figure out security. So I think for most organizations, it is not that abrupt of a shift. But I think the most interesting thing for me of talking to different folks, whether it's a CIO, a CTO, a CISO, a development lead, anything like that over the last, let's say, 5 years, is you saw a lot of organizations that said, oh, this shift to Agile or this shift to DevOps or this shift to cloud, it's not for us. Like that's only for hipster internet companies or something like that. And what's fascinating is you go back and talk to those organizations a year later or something, and let's say you're speaking with the CISO, and I can't tell you at this point how many times I've now heard, we just got a new CIO, they've mandated we be completely in the cloud in 18 months, and how do we adapt? And so I think kind of now going back to your question around, you know, the OWASP top 10 and really just even broader, what is, are things changing from a security perspective? I think they have to change. And they have to change right now more than any other time, because the way that we create and deliver software, this kind of shift to Agile and DevOps and everything, has kind of existentially changed the environment that we're operating in. Right? If you looked at, if you looked at 10 years ago versus 8 years ago for OWASP injection issues or something like that, had they changed that much? Well, not really. We were still dealing with the same kind of style of applications and still feeling a lot of the same threats. But you flash forward to organizations going through this shift now, and that's really almost every organization, and it really changes the way that security has to interact with them. And then from a threats perspective, because, kind of to your previous question, because those teams really have so many more sensitive assets now than they used to, it means that the threats that we're facing have actually really greatly expanded. I mean, if you go back to web application security 15 years ago, 20 years ago, it was like, oh, well, that was the marketing site. So who really cared? There wasn't really that many sensitive assets. We put it in a DMZ. Like, it's just not that big a deal. And I think for plenty of us that kind of came up from a network security background, that's still a little bit of the mentality that we tend to have just because it was historically true. But the reality is the world has changed out from under us, and that the web layer is where so much of that sensitive data now sits. And this shift of web applications and APIs and microservices and everything there means there's a broader set of assets, and the broader threat of threats that we actually face really now goes along with it.
Yeah, the thing is, the marketing site that no one thinks or cares about is more than likely going to be where the attacker gains their foothold.
Exactly. Yeah,
it's those little cracks.
Yeah, I say it's all of the above now, right? We have to worry about really complex business logic issues and application misuse on a bunch of our core platforms. And at the same time, if we don't patch that marketing site that everyone has forgotten, that can that can lead to issues as well, just on its own.
Yeah, or that box under someone's desk with SQL Server 2000 on it, or 2003 or whatever.
Certainly.
In regards to lack of input validation, filtering and sanitization, XSS, cross-site request forgery, the injection types such as SQLI, NoSQL, command injection, XML, XSLT, XPath, XQuery, LDAP injections, are you still seeing these as being high on the list of things software engineers need to focus on?
So I'd say there's good news and bad news there. I'd say the good news is that the platforms, like the language platforms themselves, are getting better at having really safe defaults and everything like that. The bad news, or just less the bad news and more just kind of the challenge, is that if you talk to any sort of organization and you ask them, what is your technology stack, their answer is yes. Because they have everything, right? And they're constantly bringing new ones in and everything like that. So I think the challenge from both a development perspective and from a security perspective, because really the two are merging, is, okay, as we bring in these new technologies, do they give us the same sort of controls or coverage that the last technology that we were used to working with did, right? If you have one technology that parameterizes queries for SQL for you by default, or does output encoding for you for XSS by default, and you weave in a bit of new technology to your stack, does it give the same guarantees? And so that's what I think a lot of organizations are struggling with, and why from the outside it feels like, oh, how can it be 2017 and SQL injection is still a thing? Well, the answer is because the technologies that we are working with have changed, and they probably changed 4 or 5 different times during the last time you've talked to that organization or anything there. So I think from the defensive perspective, it's really thinking about what guarantees do our different platforms give us? But I can tell you from being in the trenches on that one, what I've really learned is how do we kind of abstract the security up a layer so that we can cover the different technology platforms that our organization provides, but in a way where the developers don't have to think about that, right? If every time a developer is writing code, they're having to think, oh, does this particular framework handle XSS for me? That's a problem, right? And so we need to be thinking about how do we cover those sort of issues in a way where someone doesn't have to be asking themselves those questions every time they're writing code.
What advice do you have for software engineers to better manage data store compromise?
Yeah, I think, that all kind of weaves into this focus on shifting to how do we get visibility into what's actually happening in production, right? I think so many, over the past 10, 15 years, so much of the SDLC has really focused on, let's try to eliminate all the bugs from code before it goes to production. And that's not wrong. You absolutely want to eliminate, vulnerabilities and bugs from code before production. But the reality is your code is always going to have bugs. There's always going to be bugs that exist in production and vulnerabilities there. And so really thinking about, okay, how do we get visibility over what goes on there? And whether that's an attacker attacking the front-facing part of the application, or getting through to the data store like you mentioned, and thinking about how do we have coverage over that. What you want to be thinking about there is if I'm a developer, I want to know if my application ever just responded with a 3 megabyte response size to something that looked like a SQL injection, because that's somebody probably doing a select star out of the users table. And so really getting that sort of visibility at not just the front facing of the application, but really, where the data actually lives, I'd say is a real key to it. Absolutely.
But isn't that more of a DevOps concern?
I think what I'm really seeing with organizations that are going through the shift to DevOps, to cloud, to Agile, is that the lines are very much blurring between that. Where it used to very much be, okay, that was the SysOps group who were worried about it, or that was the security group, or the development group who were worried about this. What I'm seeing the most successful organizations really come away with as a pattern is blurring the lines between those. I think it's why DevOps really took off. Was blurring the lines between developers and operations allowed the organizations to move quicker. And from a, whatever you want to call it, a SecDevOps or a DevSecOps or whatever term we're using today there, I think what the organizations that are doing that successfully are really finding is that you need to kind of provide that visibility in a way where it's not just one group can use it, where it's the development teams, where the DevOps teams, the security teams all have the context they need so that anyone there can look at something or get an alert that says, hey, yeah, 3 megs just went out the door from what looks like a SQL injection. That shouldn't fall to just one team. The only way we scale is to really bring it across teams and really learn those same lessons of DevOps. I think it's very comparable actually to kind of the rise of AppDynamics or New Relic or any of those performance, application performance monitoring, the APM tools, is that they didn't build tools that were just usable by very dedicated performance experts. They brought that visibility across the full DevOps team, the full development teams, and even some of the security teams. And so it's really learning those same lessons of providing that visibility in a way where it's very cliche to say, but I'll say it anyway, of kind of breaking down the silos between the teams there.
Yeah, one of my thoughts around that is that as software engineers, we should be considering that our data stores are already compromised. So with that thought, we should be making sure that our secrets within the database are well encrypted with decent KDFs, key derivation functions. Yeah,
definitely, right? I think the classic blog post on that of just use bcrypt. Right, and what encryption should I use for my user passwords or anything like that? It just all comes back to just use bcrypt. Absolutely, I think thinking about storing the secrets that you store in a way that either makes it really difficult for attackers to get to, even exactly as you said, even assuming certain levels of compromise, or additionally too, not just but also storing secrets in a way that even when attackers do get them, that they're not readily recoverable. So I'd say the 2 examples of that would be, putting certain keys inside HSM. So even when you do have some degree of compromise, they don't actually get access to the raw private key or something like that. And from the other side, like I was joking about with bcrypt or anything there, right? You don't want to be storing your user credentials as a MD5 hash or something like that. You want to be thinking about, okay, how can I be using bcrypt or some sort of modern appropriate way of hashing or encrypting secrets?
It's defense in depth, right? So when an attacker can get through one obstacle, then they've got a whole lot of other obstacles that they've still got to work their way through.
Yeah, that's exactly it.
Distributed authentication, authorization, and session management is becoming complex. What advice do you have for reducing this complexity and improving the security?
Yeah, I think the one upside of one of a few actually, upsides of the kind of decentralized, the federated identification and everything like that, and kind of, SAML and single sign-on and everything like that kind of applied to the application layer, is it really does help with the credential lifecycle management and the kind of identity and access management and everything there. When you have 50 different apps and they all natively do their own authentication and everything like that, you can do things right with the individual apps, but the problem is that now you have 50 different data stores of sensitive info and you're not really sure where everything lives and everything like that. So as I've been seeing, the kind of rise of microservices and APIs and everything that rely on a central authentication scheme that they don't even handle themselves, I think the real upside is that there is kind of less surface to defend there, and it hopefully gives us a more understood model of How do we onboard and offboard users? How do we roll credentials when we need to? Kind of that full lifecycle management of credentials. So I definitely think kind of centralizing some of that there can be different than what you were used to at first, but it can actually offer some really strong security benefits.
Yeah, so there's quite a few complexities up front to work through, but once you've actually worked through those, then you get the benefits across your entire suite, right?
Definitely. Yeah, if you're thinking about in 18 months we're going to have 500 different APIs or microservices that we all want to talk together, and they each need to manage their own authentication. It's pretty quick to see how fast that does not scale and how fast that falls over. So I think there's definitely complexity up front of building, exactly as you said, building those services right up front in terms of kind of a centralized authentication. But I think it can really pay dividends over time as you scale.
Yeah. I just want to talk a little about organisational culture.
Mm-hmm.
In many organisations, we're deploying code continually. How do we make sure that security is not just a checkbox and that it's part of the development process and the software engineer's mindset?
Yeah, I think having tried lots of different things there that have failed spectacularly, and learning a lot of lessons along the way and finding a few that did over time work very well, I think the starting point, if you're a security professional or a CIO or a CTO going through that shift, the number one lesson that I really learned was you have to start from, exactly as you said in the beginning, the cultural perspective. It's not actually a technical problem at first. It's showing up from a security perspective and saying, look, let's be honest here. Security tools in the past have really been about, in a lot of ways, slowing things down and trying to have control and everything around slowing things down and assuring everything was perfect before it went to production and everything like that. And the reality is, as we're going to Agile and DevOps and CI/CD, things are going to go out the door very quickly. And the reality is, a lot of times, what we thought of as a security control before isn't going to happen until something's actually already in production. So I think the first most successful piece is really saying, look, the way that we've done security needs to change. And we're going to try some new approaches as part of this. And, there's going to be a couple things that won't work, and there's going to be some things that do. But I'd say the single most important bit is upfront, how we engage the development teams and DevOps teams with security is by being honest right up front and saying, look, if we try to keep doing security the way that we've done it, it's not going to work. It's not going to scale. And we want to be open and honest with you about that because we want to really bring effective security approaches to the table, and we need your help to do that. The only way in which we really go on this kind of journey to DevOps and cloud together securely is by working together on it. And so what we will provide from the security perspective is really working on new approaches that help you out, that you can consume. Our ask at the same time is that you let us know what works and what doesn't, and that we work together on this collaboratively. Because again, if we just keep trying to do security the way we've done it for 20 years, it just gets routed around in the shift to DevOps and cloud if it can't keep up.
We had a show with Francis Reynard on DevSecOps. Francis Reynard's the guy that started up DevSecCon.
Yeah, he's awesome.
Yeah, so that was show 288. We touched on how the rapid rate of change actually means we can make things more secure. How do you see this working with continuous deployment?
Yeah, so this was something that if you had asked me on my first day as a CISO, would this shift make us more secure? I would have started laughing and then running for a bottle of whiskey because there is, in my mind, it would have seemed like it would be an absolute disaster. What I really learned going through that shift is, believe it or not, it actually can make you more secure. And the reason is that we kind of have this new playing field to try new approaches. And the biggest thing that I really learned out of it is that no matter what your development methodology or your DevOps methodology or deployment or anything is, you're always going to have vulnerabilities. You're always going to have issues that you need to react to. And the problem with the kind of slower, older models of like a waterfall or something like that is you don't really have the ability to react. If you've ever worked in a place that does waterfall development and you've tried to rush an emergency patch out the door, you know what an utter nightmare it actually is. And so this is really how I learned the lesson, is that as you go to DevOps, as you go to CI/CD and everything there, it's not that magically vulnerabilities go away. We're always going to have vulnerabilities. It's that for the first time you can react. Because instead of needing to rush that emergency fix out the door that's a total nightmare to get all these political teams to buy in and everything like that, now it's just another deploy. And if you're in an environment that's deploying every day or every week or anything like that, it's not it's not that scary to just make another deploy because you already organizationally know how to do it. If you only deploy every 18 months and suddenly you need to deploy 6 weeks after something is found, it's a nightmare. And so this is why I really actually agree with what he said, which is that if we seize this opportunity and do it right and change the way we've done security, it can actually be a net positive for security.
Yeah, well, we get a lot better at deploying, right?
Exactly.
And the other thing is it gives us a whole lot more opportunities to inspect and adapt.
Yeah, that's exactly it.
So how does the culture of the organisation that has security as part of their development process look? And how would you go about achieving this in organisations and teams where security is seen as a blocker?
Yeah, I think so much of it is really acknowledging that right up front and saying, look, I recognize that security has been a blocker. You know, as we're going through this shift to be it DevOps or cloud or whatever the shift is, really recognizing that security has been a blocker and saying, sometimes just as explicitly as saying that, I recognize security has been a blocker. We need to find new ways of doing it and empowering the teams to be security self-sufficient as we're going through this shift. That's why I'm actually so hopeful about this shift to DevOps and cloud, is it kind of gives us this clean slate to try new approaches and say, look, security's been a blocker in the past. We recognize that. That's just kind of it came out of the whole sort of waterfall model and everything there. The way in which we build and deliver applications has changed. Security needs to change as well. And I think the first thing a successful security team needs to really do is say that up front and say, look, we recognize we need to change. We're going to be working on that. You know, a lot of times we want to hear from you, what is the best way that you could really interact with security? Is that us embedding somebody in your team? Is it training someone from your team, kind of like we talked about earlier on? It could be, you know, what tools would give you visibility or anything like that? How can we provide it? But it really, security in a lot of ways almost shifts to becoming an internal consulting group. That really, it needs to make its customers, which are the development teams and DevOps teams, happy. It can't just show up and say no, because what I've actually seen there is that the security teams that don't adapt, it's not like the business stops operating. The development teams and DevOps teams just stop speaking to security. It's really a lot, right? It's crazy. I think security teams are at this inflection point that like IT procurement teams were 8 years ago at the start of cloud, where they said, oh yeah, anytime you want a server, it's going to take us 12 months to procure one. And so the development team said, great, we just put down a credit card, we spun up 8 different instances, and we don't need to speak to you anymore. Security's at that same inflection. If they keep being a blocker, they're going to get routed around.
So I have worked for quite a few organisations in New Zealand. I'm wondering whether this is a New Zealand specific thing or not. I'm not sure. But how would you go about changing the culture of an organisation where the development team is just not interested in security and developers dictate the direction of the organisation?
Sure, yeah, and I don't think that's necessarily just a New Zealand thing. I think certainly over my career, I've seen plenty of organizations where that has been true. And I would say that you know, it may sound wildly optimistic, which security people are not usually accused of being, but I really think that that's actually improving over time. It's really something that I've certainly seen in my career change over time, really regardless of locale. You know, some locales move at different speeds than others or change at different times, but I've really, on the whole, seen that start to shift. So I'd say that's the good news up front. I'd say specifically how you try to shift organizations or how I've seen organizations like that shift in the past is a lot of times, and it's kind of going back to some of the things I sound like a broken record on, but it's providing them with security tools that they can use themselves directly. I mean, putting yourself in the developer's shoes where they're very antagonistic to security, I think a lot of times it's because the only security product or anything that they've used spat out a 100,000 page report of which 99,000 pages of it were false positives, and they're like, well, this is useless. Like, I'm not interested in working with this sort of thing. So really giving them actionable information and tools that they can use directly, a lot of times that's the right starting point. It's just showing that, look, there can be value for you here in a way that is not going to cost you a ton of effort or time or anything like that. And so I think half of it is kind of cultural, like we talked about a minute ago, of really coming to them and saying, we recognize things need to change. And the other side is then technical and really saying, hey, what data would be useful to you from a security perspective? I recognize that you don't want to, you view your job as writing new features or writing new product. You don't want to be bogged down with heavyweight security. What would be kind of light touch security that would be useful to you? And really starting from there and working with them on that.
We've got to make their lives easier.
Exactly.
Do you have any tips on getting developers to the point where they actually enjoy security, where it's something they want to do?
You know, this sounds so simple, and I couldn't believe the effectiveness of it, which was when we started at Etsy, we really started investing in visibility and really starting to say, okay, we need that kind of visibility into attacks and anomalies that are happening across our applications and our APIs and everything like that. What we did at first is we made kind of dashboards and everything like that, and we just used them ourselves as security folks. We put up some dashboards in our security area of the headquarters and everything like that. And to your point and to your question, the most interesting thing we found is we had a couple folks walk by and go, oh, what's that? And we'd say, oh, actually, if you take a look here at this data, that's somebody attacking your service right now. And what was fascinating is you'd see these developers that I had thought, maybe at first didn't care about security or were ambivalent to it or something like that, go, wait, what? Seriously? Like, people are attacking my service? And, from the security side, we'd be like, of course they are. I mean, that's just second nature that you assume that you're under attack all the time. But a lot of times when you speak with folks on the development side or the DevOps side, they think they need to be explicitly targeted. And not that, folks are just attacking all the time. They're really, they're throwing attacks out there and they're seeing where they have success and they're pivoting against those. And so our lesson learned on that was if we brought visibility to the engineering teams, they really got way more into it than we ever expected. I think, a friend of mine put it really well. They're like, yeah, name an engineer that doesn't get excited about some new graph of data that they've never had access to for the first time. And I was like, well, when you say it like that, yeah, it sounds blindingly obvious, but it took us a long time to learn that lesson, which is if we can give them visibility, suddenly it's really, really interesting. And that they can start to self-serve and say, oh, this is somebody attacking us over here. Like, we want to, maybe those bugs that we thought were totally theoretical and we were going to prioritize them off in Q4 of the following year, actually we see somebody attacking that service today. So yeah, we are going to bump up the priority of those here. Really, yeah, making it interactive.
Auth0 is the easiest and fastest way to implement authentication and authorization architectures into your apps and APIs. Allow your users to log in with username and password, social and enterprise identity providers such as Facebook, Twitter, AD, or Office 365, or without passwords using Slack or WhatsApp. Getting started is very easy. Use one of more than 40 SDKs and add a few lines of code. No credit card required. Get the free plan at auth0.io/SERadio. That's auth0.io/SERadio. Auth0 is trusted by developers at Atlassian, Mozilla, Optimizely, and Financial Times. Try it out at auth0.io/SERadio and get back time building core features.
We've got a section on visibility that we're going to shift into shortly. Mm-hmm. You mentioned access policies in one of your talks, building a modern security engineering organization. Mm-hmm. How startups basically don't have them and how important it is as an organization grows that they need to implement access policies, but not to remove capabilities from the engineers. You had some good examples on how you would implement solid access policies throughout the organization without removing capabilities. Could you share some of these?
Yeah, definitely. And those were very hard-learned lessons because I screwed it up plenty of times along the way. So I hope everybody gets to learn from my pain, which is that, at first the reaction can tend to be, whether it's you're a new security person coming into a new organization or whether you're a security person or a development team, a developer or a DevOps engineer that suddenly finds out about either a new acquisition that the company made or a new cloud project that's going on. The first reaction can just be, oh, we need to shut down all access immediately while we figure out what's going on. And the reality is that, the engineering organization doesn't just grab a bunch of access because they feel like it would be fun or something like that. People tend to have that because it's how they're getting their jobs done. And so I think the first lesson is not just blindly restricting access or something like that when something feels unsafe, but rather figuring out what the capability actually is that different developers or different DevOps engineers are using and building a safe way to do it. So I'll give you an example that I think plenty of us have lived through, which is development or DevOps access to production. And at first that seems scary that, okay, SSH is on every box there and everybody has keys to access everything and everything like that. And so the first reaction is, oh, shut everything down. The reality is like, okay, well, why do people ever actually, why does a mid-level developer on let's say a front-end team ever SSH to production? That seems crazy. Well, when you go ask them and talk to them, more often than not, the reason is so that they can actually get debug logs. Right? It's, oh, we got some sort of report about an issue. The steps to reproduce the issue weren't correct or were totally missing. And so we want to pull some logs to actually try to figure out what's going on so we can root cause this bug and fix it. And that's a very sensible reason, right? That's part of their job. And so what you kind of build back from then is, okay, well, they don't need access to production. They need access to logs and data so they can do their job. And so what you start to think about then is, okay, well, how do we pull logs off production hosts, bring them back to a centralized logging host, surface those via some sort of tool, whether it's a Splunk or an Elk or a Sumo or something like that, and do it in a way where folks can get the data they need, but it's controlled, and we've really reduced access. So over time, you're then able to kill off that SSH access and reduce your attack surface, but you didn't get rid of the capability that the engineer needs to do their job, which was view logs and kind of root cause bugs. And so that's really the lens I'd recommend thinking about it through is think about what the capability they actually need it is, and don't treat the symptom, which would be access to production, treat the underlying cause there.
Leading up to the show, you mentioned improving phishing and security awareness training. It's a common understanding that trying to teach people not to click phishing links doesn't work. How do you go about making security awareness stick in the minds of everyone involved in the development and ops process?
Yeah, I'd say there's kind of two sides of security training. There's the general like security awareness and the phishing and all of that. And that's where I'd say the biggest shift that we need to go through and the biggest lesson learned I had was you're not trying to train people down to where no one's ever going to click a link, because the reality is that's never going to happen, right? You're never going to be able to drop that number to zero of people who click on potentially dodgy links. What you can train up and raise over time is the number of people who report when they get something like that to security, whether it's they just saw it and it looked fishy to them and so they want to report it, or even they clicked on it and then they said, actually that seemed a bit strange, let me tell someone there, and and you really want to reinforce that they're not going to get in trouble, that they're really going to get rewarded for reporting things like that, because all you need is one person to report it so you can start your kind of DFIR and security operations process, or incident triage or anything like that. And so you really want to raise the number of people that report those. At the same time, of course, you want to try to train people to click on stuff less, but the reality is that number is never going to go to zero. So I'd say that's one side of the house, which is the kind of phishing training and everything there. The other side of security awareness training is for the developers, right? Developers, DevOps teams, and training about secure code creation or delivery or anything like that. And again, I think the way that we've done training there, just like with the phishing training, can actually be kind of turned on its head, which is in the past, we've really tried to do the training to get people to write perfect code, basically, which is, here's an anti-pattern, never do this, always do this instead, or always do that instead. And the problem is everyone sits through those trainings. They're usually all day long. They are tremendously boring, and I say that even as a security professional, and everybody walks out of there bored and not remembering it and just saying like, man, I should never talk to the security team because they are incredibly boring. What we actually want to focus on there, and what I found successful, is the metric you want to be tracking out of your security training for the development side of things is how many people engage with security, how many people and how frequently people engage with security afterwards. I don't expect developers to walk out of a modern security training and say, I now know how to write perfect code. What you want them to walk out of there with is, hey, these seemed like areas that were things that the security team had done some sort of training around. I'm going to go ask them for their input on this as I'm designing it or as I'm writing it or as I'm, implementing it or anything there. Really kind of just like the phishing side of things, which is you want to be driving engagement out of that. You want people to reach out and say this link was fishy, or you want people to reach out and say, hey, I'm going to be collecting this new form of user data. how should I protect it? I was thinking hashing, but I don't know, is that the right use here? And that's really the thing to be tracking. And the way I found it the most effective to actually do that, a lot of times with folks, is for that training, the less theoretical, the better. And so what I found there is a lot of times even just rolling back issues that have real vulnerabilities that have happened in a particular code base that the organization owns, so maybe a mobile app or a web app or something like that, and roll them back and teach the developers off of those. Those are real issues that have actually happened to the organization in the past.
Yeah, the way I see that is it's like trying to teach the C-levels how to code, and they just, they're not going to get it, so don't do it. So just build relationships with them instead, so that when they have issues, they come to you and ask for your expertise, right?
That's exactly it, yeah.
I've got a question on threat modeling now that basically sprung up with my discussion with Haroon Mehr.
Mm-hmm.
In my discussion with Haroon on the Network Security Show, Haroon mentioned that penetration testing hasn't been that effective in creating attack-resistant systems, and that a very effective threat modeling technique was to have a red team or attacking team member as part of your development team and work out the possible ways of breaking into whatever it is that you're working on. And then to have the blue team, which is the defending team or the development team, members question the red team individual. How would we notice this thing happening? You then design your monitoring and alerting around what would have caught this attacker. I've noticed a similar theme in your attack-driven defense talk. In terms of application security, what would you add to this threat modeling process?
Yeah, so first of all, just kind of a side note there, I completely agree with that methodology. I mean, I think Haroon is one of the smartest people in security. He's absolutely fantastic. And so totally agree with that methodology. What I found successful there is, it's something you mentioned briefly in that, which is not just, how did you find a particular issue or anything like that, but asking yourself as a development team or DevOps team the hard question, which is, how would we have known? How would we have detected this? How would we have, if we did detect it, how would we have known that somebody else hasn't exploited it 6 months previously, or that this attacker didn't find something else there? And I think this really goes to the heart of the penetration testing question that you said, which is that the problem for most organizations is that pen testing isn't really pen testing. Pen testing is kind of, I'd say, better described at this point as vulnerability enumeration. Right? You get this big report at the end that says, here's a stack of vulnerabilities, and you go fix them, or you go upgrade, or you go patch, or something like that. The problem is that that big stack of vulnerabilities is not how an attacker actually attacks real systems. And I say this as a former and recovering pen tester myself, which is that big stack of vulns, often it's like, okay, the criticals and the highs are what everybody focuses on, and then you ignore the mediums and the lows. The reality as an actual attacker is often it's a series of lows or mediums that you chain together that make for the really effective attacks of how you actually compromise an organization. So I'd say there's a couple things here. One is running those more realistic red team simulations, which is not just discover a bug, report that bug, and kind of operate in isolation, but rather try to actually get at real data. And for the blue team side of things, whether that's a security team or development team or DevOps teams, asking yourselves, how would we detect this? How would we make this harder for the attacker? How would we get the visibility that they had just discovered a real bug, or that they started exploiting it there, or that they'd actually done all of that without us detecting, and now they're exfiltrating data, and maybe we detected that point? Or anything like that. And so I think people are starting to do that from the kind of endpoint and infrastructure side. And where I see the more modern organizations going right now is recognizing that the application level is kind of the next big piece to tackle there.
So I'm just going to move into a section around visibility now. Mm-hmm. What are some of the risks of lack of visibility, insufficient logging, and monitoring?
Yeah, it's exactly what we actually just went through on the previous question in a lot of ways. Yeah. Of the risks there that you don't know, right? I forget the stat, so I would probably completely mess it up, but from the Verizon data breach report, the percentage of organizations that are told by a third party they've been breached is staggeringly high. I think it was the number one way in which organizations find out is that they never even detect it. They get told by somebody else that they've been breached. And so that's the cost of not thinking about this from the vulnerability or from the visibility perspective, is that you get breached and you don't even have a chance to react or to try to cut off the attacker halfway, or ideally prevent the attacker from getting that data at all in the first place.
Yeah, like the organization gets told that their IP address is sending attacks.
Right, exactly, right? You get a call from Brian Krebs or the Wall Street Journal asking for comment on why your data is up on Pastebin. That's not an effective security program.
Yeah, so how do we build logging and instrumentation into our applications to capture security defects and attacker activity?
Yeah, I think the first point is, and this is a really nuanced and deep topic right there that we could spend hours on just by itself. So I'd say the starting point is you start with what you have. Every organization has some logs or something like that. Just like when we were talking about with taking away access but not capabilities, this is really where you get 2 for 1 out of that. You reduce that access of, in that example, SSH access to production, but at the same time, it really sets the groundwork now for the visibility side of things, which is, okay, if we have our logs in one place, now we can start to build kind of visibility on top of those. Now, the challenge that you run into real quick there is that the logs are never as complete as you want them to be. A lot of stuff never even makes it to the logs. Like if you're dealing with, your web applications and your APIs, a lot of data about your GITs, your HTTP GITs gets logged, but your HTTP posts, where all the data is actually in the post body, that doesn't make any logs because you don't want to log sensitive data like that. So you recognize some of the walls that you run into real quick, but the starting point is absolutely your logs, and then you start to recognize the value from it, and you start to move up and say, okay, how do we get deeper visibility into the actual application or anything? Now, the details of exactly how you do it obviously vary by organization and technology and everything like that, but the methodology is really the same across organizations, which is you start from logs, you recognize that gives a good starting point for visibility, and then you recognize, hey, we need deeper visibility into where the application logic actually lives, and at the same time, we need the ability to react, because logs are inherently reactive, and you ultimately want to be able to be proactive of this sort of stuff and block attackers and stop attacks there.
We also need correlation between the different logs as well.
Exactly.
Because attackers are moving across the systems, right?
Totally agree.
I want to discuss monitoring and statistics graphing for application security. I've covered StatsD, CollectD, Carbon and Graphite as one solution in my book series. As a previous director of security engineering at Etsy, can you explain what this sort of setup gives us and how we capture security defects and malicious events using it?
Yeah, so I think the running joke at Etsy was always, if it moves, graph it, and if it doesn't move, graph it just in case it decides to make a move for it. And so the challenge, the first thing is just kind of getting that sort of data, right? Getting the graph data, getting the logging data and everything like that. What you quickly realize out of that is now you're drowning in data. And so what you start to think about then is, okay, what are the most actionable things that I can start to surface up? What are anomalies across my application requests or the responses that my application is sending or anything like that are going to be useful not only from a reliability perspective and a performance perspective, but also from a security perspective. And then from a security perspective, let's start to correlate that with attacks, right? Let's get some graphs around when people are attempting SQL injection or cross-site scripting or anything like that, and let's start to correlate those, because just because there's a spike in SQL injection, that's probably just another day on the internet. What you actually want to know is are we seeing spikes in attacks that are also triggering anomalies in our applications and indicating that they're discovering real bugs, whether they're exploitable or not. So you start to build off of the base that you build off of is getting that sort of data at all. Then you start to build more and more actionable data on top of it. And that's going to be a little bit different for every organization, but the overall methodology there that I kind of described is really the same for everybody.
Can you explain how we capture high fidelity information without the false positives and missing events we should be catching?
Oh, yeah. That's that is a very good question. That is something that is a challenge for almost every organization. I mean, the funny thing and the caveat here and the full disclosure is this is why we actually left Etsy and built Signal Sciences, which is a product that actually does all of this for you that you can just drop in to get that sort of coverage. I'm not here to be a vendor shill. Nobody needs to hear more about vendors, myself included. But this is a really challenging problem that we spent a ton of time building out in-house at Etsy and trying and failing and finally having some real success with. And that's the reason we actually spun out a whole company and with a product around this. The big thing I would say for everybody there is getting away from the kind of classic legacy signature-based approaches of, if you looked at the only things that have ever existed in the space, and it's things like legacy WAFs, like web app firewalls. And the problem is they were just, big piles of signatures and regexes in a box. And the problem was everyone who's worked with real production applications before knows how weird they are, knows how production traffic is much stranger than you would think before you've worked with it. And so the amount of false positives that those sort of things trigger all the time is staggering. And so I think getting away from that sort of approach and really starting to think, what are practical anomalies that exist regardless of the scale of the applications, that's really the good starting point. And then it gets a lot more complex from there.
Haroon Mehr mentioned in the network security show that IDS's intrusion detection systems demo well, but largely don't work that well in enterprises. Basically for what you're just saying.
Yep.
When the representative gives a demo on their IDS, it detects the attack, but most real attacks just look like normal user traffic. So IDSs in most cases are not catching the real attacks. It looks like the Etsy TripYarn host intrusion detection system attempted to address these concerns. How well did this work, and what advances have there been since you presented this talk in 2013?
Yeah, so completely agree with IDSs there. As Haroon was saying, he's spot on. And I'd say it's actually even worse than that. It's that you lose both ways. It's that they demo well, but that's not how people attack systems. But then at the same time, when you put them in production, those signatures tend to match on a whole bunch of things that are completely legitimate traffic. So you lose with false positives and you lose with false negatives. And I think that's been completely the case with both kind of legacy IDSs and legacy WAFs there as well, the web app firewalls. So that the IDS side of things, yeah, that really led to the creation of TripYarn, which was based off of an awesome talk out of Facebook that they had built something kind of homebrew around that, and then Etsy built TripYarn. What's funny is what became TripYarn, or what TripYarn has become today, is actually OS Query. So if you've heard of OS Query, that's come out of Facebook, that was actually initially a joint open source release called Midas between Etsy and Facebook, which was built off of TripYarn. So it all kind of goes back to the same thing. So OS Query is kind of the modern one today there. And yeah, there were a bunch of good lessons learned around that. I think really aiming for, on the host intrusion detection side of things, it goes back to, I think, one of the first points of the conversation, the first question that you asked, which is around how attacks are changing. And it used to be very that kind of network and infrastructure-driven attack where you'd put a IDS out there off of a span port or something like that. And now how do people attack organizations? They attack the web applications and they attack the endpoints. And so shifting to covering the endpoints there with kind of a modern approach to host intrusion detection and really looking for attacker activities and not for some sort of signature is exactly how you go about it. And really, it's the same philosophy at the web application side of things. It's not just looking for a signature for SQL injection, but looking for how do people abuse the business logic of the application to get the data that they want via what seemed like legitimate functionality.
You mentioned in your attack-driven defense talk that in practice, sophisticated persistence mechanisms, aka malware that want to persist or set up shop, won't be detected, rather aim to detect the basics. Can you elaborate on that some more?
Yeah, definitely. I think that oftentimes our industry gets so focused on like the shiniest object, the coolest 0-day, the most advanced persistent mechanism. And so you start thinking about, okay, well, will my new approach detect that? And like, no, it won't. Well, then it's worthless. The reality is that the perfect is very much the enemy of the good. Alex Stamos puts this really well, and he talked about in his keynote at Black Hat this year of security nihilism, right? And saying that, in this one edge case, it won't be perfect, so I shouldn't do anything at all. The reality as actual practical defenders is the opposite. It's that you want to make your adversaries have to do the most advanced possible things because that's incredibly expensive and that's incredibly complex. And the reality is that they're probably going to mess something up along the way that you detect. And so you want to be thinking about how can I make sure that, I detect the most low-hanging low-hanging fruit of persistence mechanisms. Then, and lateral movement and things like that. Then how can I detect the semi-advanced and then the advanced? And if I have to make my attackers, have to use the most amazing persistence mechanisms, great, I've really won because I have shifted the set of attackers that can successfully attack me down to such a small set of people. I made it so expensive that that's really the best possible outcome I can go for, right? It's not the advanced 0 days and amazing persistence mechanisms that are owning everybody up today. It's the off-the-shelf stuff. It's the landing on the endpoint and just moving via credentials that you found from there because two-factor auth isn't enabled and there's no HID sitting on the laptop. It's the web application that nobody has visibility into and there was no rate limiting, and now the totally legitimate interface for querying an ID, somebody just scripted that up and did 10 million of them before anybody even noticed. And so it's these sort of practical things of how we actually get compromised that we need visibility in place for and to force our attackers to actually be more advanced.
You mentioned in one of your talks building a modern security engineering organization that the cost of attack has significantly dropped. Do you have any statistics on that, and can you explain what you meant by it?
Totally, because that's one of those where the reality is more nuanced than that, but when you've got to distill it down into one bullet point on a slide, I think some of the nuance can very much get lost. I'd say, there are a bunch of different groups of attackers. You see them oftentimes bucketed as state level or hacktivist or IP focused or, whatever. The reality I'd say is the cost of attack for a lot of groups can be very expensive. But in general, if you are just somebody that is, has general kind of engineering literacy and you wanted to go download a tool and download a tutorial to attack systems, and you tried to do that 20 years ago, the tools were less available, the techniques were less published on, or you really had to go searching for them or know somebody or learn from peers or anything there. You look at kind of modern tools and techniques and what's available, and they've really proliferated, right? There's a bunch of different kind of step-by-step guides on how you attack something and a nice GUI tool to go do it for you and everything like that. And so I think for vast swaths of attackers and a bunch of different attack groups, cost of attack has very much gotten cheaper because you just launch, automated tools against everything, and then you pivot to the ones that you're actually seeing success with. And so you don't have to go hyper-target one organization and really try and fail and try and fail and try and fail and eventually get in. You just launch attacks on everybody and you go focus on the ones where you're actually seeing success. And so I think for those groups of attackers, cost of attack has really significantly dropped. I think for other groups of attackers, and I think it was Phil Venables, who was a CISO of Goldman, said this really well, which was, attackers have bosses and budgets too. And I think it's absolutely true for a lot of different groups of attackers there. So you want to make things not economical for them. And that kind of goes back to our previous point, is make them have to use the most advanced thing. Don't stress over the fact that the most advanced thing might work. It's that you should be rejoicing because everything else you did made everything that was cheaper not work for the attacker.
How do you go about increasing the cost for the attackers? What are some ideas?
Yeah. So I think that what we're really seeing is this fundamental shift in security approaches of the last 20 years has really been focused on this idea of prevention, right? Put the magic box out there and it will stop the breach. Buy the antivirus and it will stop the breach or something like that. What we're really shifting to, and what I think is the fundamentally just more effective approach, is the notion of detection and visibility. Right? It's not deploy the magic box that will stop it and you'll never know anything about it. It's get the visibility so you can detect an attacker as early as possible in the attack chain and detect them when they're doing recon or when they first gained a toehold via a application or an endpoint or something there, because that's how you can really iterate and start to increase costs for them. If they only get a toehold in before you detect them and you're able to re-image that machine or patch that application, that means it's really expensive for them because they didn't just bypass a prevention mechanism and then no one even knew they were there and they were able to move through the rest of the attack chain. You want to make the attackers scared that they're going to be detected at every level. And so they have to operate really cautiously or anything like that, and then you detect them via a different way, right? It's the focus on that visibility and detection so that you can shut them down as early as possible in the attack chain. And now they need 100 attempts to do something where they just did an evasion of your prevention mechanism before and they only needed one attempt to get by that. And so those 100 attempts are going to be way more expensive than that one.
So what about bug bounties, attack simulations, and penetration testing? Do you want to just explain for the listeners what bug bounties are and how effective you think they are, and also attack simulations?
Yeah, so I absolutely love them. So I would say bug bounties, for those who aren't familiar with them, are essentially a program where you can say as defenders, hey, security researchers, if you look for these type of issues and you look for them on these specifically scoped systems or applications or anything there, and you play by these rules, then if you report those issues to us, we will reward you in some way. That might be monetary rewards. It might even just be a t-shirt, or it might even just be putting their name up on a hall of fame of people who found issues or something like that. And the reason why it sounds so straightforward, but the reason why these programs exist historically is that if you were a security researcher and you found a vulnerability in some sort of company in their applications or their infrastructure, and you reported it to them, you had probably a 50-50 chance of getting sued. It was really scary to report those issues, even if you were very well-meaning. And so bug bounties are really cool because they can let everybody kind of act in good faith. You can say, hey, researchers, if you behave in this way and play by these rules, we're going to reward you. And researchers, if they go play by these rules, can go get rewarded for things. And, really work on their techniques and, cool ways of finding new bugs and everything like that. So it really is a win-win for folks if done right. Why I really like them, having been on all sides of them now in my career, is that they, I think, are, in general, they're very good at the things that pen tests are kind of weak at, and pen tests are very good at the things that bug bounties are weak at. And the reason for that is that bug bounties can, I'd say in the general case, they can give you really good broad but kind of shallow coverage. So they can test a lot of different attack surface, but they're not actually going that deep on it. Whereas pen tests, whenever we've all kind of done pen tests, the problem is you typically get a few pen testers for a few weeks, and you're always stuck with this really bad choice, which is, do I ask them to try to cover a ton of stuff, and I know that they won't go that deep on it, or do I ask them to focus on just a couple areas, and they'll go really deep on that, but they won't cover really anything else? And so the two really augment each other, because now you can use your pen tests for very focused things. Right? I want you to go very focused on this particular API or something like that. And then you can use your bug bounties for that broad coverage. And then how they all kind of chain together into a really effective attack simulation is that you can use all of these as a feedback loop into the way that you're thinking about visibility. So what you start to think about is, okay, this bug bounty participant or this pen tester found this bug. How would we have detected that? And how would we know that they didn't discover 10 other things that they're not reporting to us? Or how do we know that somebody 6 months earlier found the same thing and has been exploiting it for 6 months before this person actually found it? And the answer is, when you ask yourself those questions at first, you're going to be really unhappy with your answers, because for most organizations that have not started going through the shift yet, you don't really have an answer. And so that immediately guides how you start to think about visibility and getting that sort of coverage.
And that's another good reason why you get the red teamer into the development team, right?
Exactly. Yep. You want that feedback loop, right? It would be like if we deployed an application to production and then we said, oh, that's it. We don't need to monitor its performance or its reliability or anything like that. I'm sure it's fine. That's kind of where we're at with security, right? We've got these applications in production, but you need that visibility in, so when there is an issue, you can detect it and you can react. It's just like with performance. If suddenly all of your production web servers CPU spikes, you want to know about that before somebody calling you saying that I can't use your site because it's down.
What interesting personal projects or events do you have on the go currently, Zane?
Yeah, so I'd say the blessing and the curse of starting a security company is that it is the vast majority of your time. But I'd say, so it's personal projects and work projects definitely overlap the vast majority at this point. But I'd say the most exciting one for me there has been really focus on getting people coverage across this broader spectrum of threats that they actually face at the web layer, right? Getting people coverage through SQLi and XSS and all that, sure, that's important, and we do that and everything like that. But I think what's been most rewarding to me is getting people that coverage over the business logic and the application misuse and the application DDoS and everything there, and getting people that sort of visibility. So for me on the personal project side, it's just kind of continuously feeding back into the product around effective ways of giving people that sort of coverage.
What have we not discussed that we really should have in this show?
Man, good question. And also, I think we've covered a bunch of great stuff. I mean, I think that I think you really nailed it with a bunch of the questions and a bunch of your points around, this shift to DevOps and cloud. It feels scary. It feels like it's going to make things worse. The reality is it can actually make things better. At the same time, bringing these kind of effective security controls in a new way is really what helps enable the development teams and the DevOps teams, especially those that have historically not been interested in talking to security because it's been so heavyweight and has been such a blocker. And then really thinking about that all through the terms of attack simulations and effective red teams, and thinking about that as a feedback loop into visibility that you can use to empower the rest of the organization. I mean, those are far and away, those themes are what I see across all of these kind of leading enterprises that are handling this shift really well.
Where can people find out more about you and what you do?
Signalsciences.com. I'm on Twitter as well at Zane Lackey because I am not creative at naming a Twitter handle there. And honestly, if you're going through any of this sort of shift, I think we're all facing the same challenges. And so something that's really rewarding to me is I love having conversations with folks that are going through the shift and just sharing lessons learned with each other on it, because at the end of the day, we're all fighting the same battles on this, and the more that we can help each other, the better. So I actually have open DMs on Twitter. My email is Zane at Signal Sciences. If you're going through any of this and you just kind of want to chat with a peer who's gone through it and you want to avoid some of their pain, I'm more than happy to share with you a bunch of the stuff that we didn't get to deep dive as much in here or anything like that. So however I can be helpful, please just give me a shout.
I'll throw some links on the show notes around that as well. Do you have any other recent podcasts or conference talks that you think would help our listeners understand what aspects of application security we should be focusing on?
Yeah, I did a talk at Black Hat a couple months ago on the way in which to adapt the kind of individual pieces of the SDLC. So how do you change static analysis? How do you change dynamic scanning? How do you think about visibility and everything like that? That it might be worthwhile to folks here. I think they've posted videos now. If not, you can just email me and I'll send you the full deck and everything like that. And that's been the main one I'd say recently. And then I'm hopefully working on some new material for a few different talks next year, one of which I'm actually hoping I'll be presenting. You mentioned Francois at DevSecCon in Singapore in February. So hopefully I'll be out in that area in a few months.
Cool. Hey, Zane, thanks for joining us today.
Hey, thanks so much for having me on. Really enjoyed the conversation. This was super fun. Thanks again.
For Software Engineering Radio, this was Kim Carter.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.